Hello, my name is Alex Hubble, and in this video I will be demonstrating the different sort algorithms for array lists in Java programming. I will be demonstrating using playing cards. These playing cards will be arranged in unsorted order, so like 7 at the start and 1 at the end or something. I will be demonstrating the selection sort first, and then I'll move on to the insertion sort, and then the merge sort, all three sorts. Eventually all three sorts sort an unsorted list in an array list. So let's start with the selection sort. Okay, so in a selection sort, here we have our unsorted list with 9 values in it, 9 elements, sorry. See, we start with random numbers. They're all unsorted. Maybe some of them are in the right order, I'm not sure. But here we have this. So with selection sort, we're going to start with the first value. Now this value is going to be set to our minimum value. Now in selection sort, we start with the minimum value and then we move on to the next one. We see if this value is smaller than this value, then this becomes our new minimum. So then we move on to this value, and if we see if this value is smaller than this, which 6 is not smaller than 4, so 4 stays as our minimum value. So we move on to the 2. We see if 2 is smaller than 4, in which this case it is. So 2 becomes our new minimum. So then we go to the next element and we see, is 5 smaller than 2, which is no. And then we see if 3 is smaller than 2, no. 9, 8, and 10 are all smaller than 2. So in selection sort, we get our minimum value and our first value, and then we switch them. So the minimum value goes to the start of the list, and the 7 will replace the 2. Okay, and then we move on to the next value. So this becomes our newly sorted list. And this is the unsorted portion. So this is the sorted portion, this is the unsorted portion. So we start with the first element of the unsorted portion, which will be the next element in the list, which is 4. So we set 4 as our minimum value. So we move on to 6. We see if 6 is smaller than 4, which is no. And then we move on to the next element, which is 7. Is 7 smaller than 4? No. So we move on to the next element, which is 5. Is 5 smaller than 4? No. Then we move on to 3. And 3 is smaller than 4. So 3 becomes our new minimum. Then we see if 9 is smaller than 3, which is no. 8 smaller than 3? No. And 10 smaller than 3? No. So 4 will switch with 3, and 4 will replace 3 in its old spot. So then 3 becomes part of the new sorted list, and then 6 is the start of the unsorted list. So then again, we start with the first element in the unsorted list, which is 6. So we see is the next element in the unsorted list is smaller than 6, because 6 is our new minimum. 7 is not smaller than 6, so we will move on to 5. 5 is smaller than 6, so 5 becomes our new minimum. Is 4 smaller than 5? Yes, so 4 becomes our new minimum. And then is 9 smaller than 4? No. Is 8 smaller than 4? No. Is 10 smaller than 4? No. So 4 will replace the first element in the unsorted list, and they'll swap positions, and now 4 becomes part of the new sorted list. So then we start with the unsorted list, sorry. So we have 7. We check the next element in the unsorted list, which is 5. Is 5 smaller than 7? Yes. So 5 is our new minimum. So then we move on to 6. Is 6 smaller than 5? No. Is 9 smaller than 5? No. Is 8 smaller than 5? No. Is 10 smaller than 5? No. So 5 replaces 7. and becomes a part of the sorted list. So now 7 is the first element in our unsorted list. So we take 7, we go to the next element in the unsorted list, we see 6. Is 6 smaller than 7? Yes, so 6 becomes our new minimum, and replaces 7 as the old minimum. So then we check the next element, which is 9. Is 9 smaller than 6? No. Then is 8 smaller than 6? No. Then is 10 smaller than 6? No. So 6 replaces 7 and becomes part of the new sorted list. So this is our sorted list. As we see, it is coming out great. And this is our unsorted list. So we have 7 as our new minimum and the first element in the unsorted list. So we check, is 9 smaller than 7? No. Is 8 smaller than 7? No. And is 10 smaller than 7? No. So 7 becomes a part of the sorted list, and it just does not get replaced with anything because it was already in the correct index. So then we move on to 9. 9 is the first element in our unsorted list. Is 8 smaller than 9? Yes, so 8 becomes a new minimum. And is 10 smaller than 8? No. So 8 replaces 9 in the list. So then, even though this might look sorted, the Java does not know if it is or not. So this is still our unsorted list. So we check 9. 9 is our minimum. 10 is not smaller than 9. So 9 stays here. And then 10 is the last element in the list, so it stays its spot. So now, with the selection sort, we have our new sorted list. Now we have the insertion sort. So I scrambled the list again, so now we have completely scrambled numbers. It's an unsorted list, completely unsorted. So with the insertion sort, we start with the first element. This element becomes part of the sorted list. So what I'm going to do with the sorted list is I'm going to bring it down just a little bit. So now with this new sorted list, we check the first element in the unsorted list, and this is a 3. So we see, where can 3 go in to the sorted list? So 3, we'll have to slide 6 over, and then 3 goes right here and inserted in like before 6. Okay, so now we have our new sorted list and our unsorted list. So with 4, we see, where can 4 go into the sorted list? So we see that we have to move 6 over, and 4 will be inserted in between the 3 and the 6. So this becomes our sorted list. So then we take 7, for the first element in the unsorted list, and we see, where can it be implemented into this sorted list? We see it just drops down and inserted at the end. Okay, and now we have 10. 10 will be similar to 7 because it is greater than all of these items in the list, so nothing moves, and 10 just comes down here at the end. So now we have our new sorted list and our unsorted list. We take the first element in the unsorted list, and we see, where can we insert it into the sorted list. Now we see it's in between 7 and 10, so we move the 10 over, and then insert the 8 right there. So now we have 2. 2, we see, where can this be inserted into this sorted list? And we see it goes at the very beginning. So all of these elements have to move over and make space for 2 at the index 0. So now we have our sorted list with the new 2 at the start. So we take our unsorted list, we take the first element, which is 9, and we see, where can we implement this, or where can we insert this into the sorted list? And we see it goes in between 8 and 10, so we move 10 over and put it right in between, right there. So now we have 5, the last element in the unsorted list. We see, where can 5 go in this list? And it goes in between 4 and 6, so we have to move all of these greater elements to the side, and then put in 5 right there. So this becomes our new sorted list. That is insertion sort. So now I will describe the merge sort. So we have our scrambled unsorted list. So in the merge sort, what we do is we take all these, this whole list, and then we divide it in half. So right here, so this becomes a new list, and this becomes a new list. So we take the left half of the list, the half the list, and we then split this in half too. So this becomes in half, and this becomes a half. So then we take this, and we split this half too. So this comes a half, and then this becomes a half. So then what we do is we're going to merge the two recently split lists. So this is a list, and this is a list. So when we merge these, we sort them. So 9 compares 2, and 2 is less than 9. So 2 becomes first. And then we move on to this. This is also half, so we look at 8 and then 5. Then this is a list, and this is a list. So when we merge these lists, it becomes 5 is less than 8, so it becomes in front. So this is our new list, and this is the list. So we're going to then go back in the order of which we split, which is then these are the original left half of the list. So we're going to merge these back together. So we merge this with this list. We compare 2 to 5. 2 is less than 5, so 2 becomes the first element of the new list. And then we see 9 to 5. 5 is less than 9, so 5 comes down here and as the second element. Then we see 9 to 8. 8 is less than 9, so 8 comes here, and then 9 to nothing, and so 9 just comes right here. So this is the new sorted left half of the list. So then we move on to the right half, and we do the same thing that we did on the left half, which is split this in half. So this becomes list, and this becomes list, and then we split this in half. So 6 and 4 become a list. So then we're going to merge them back together. So 6 merges with 4, and 4 is less than 6, so 4 becomes the start of the new list. So then we check the right side of the recently halved list, and we split this in half too. So the 3 and 10 come over here as a new list, and the 7 becomes its own list. So then we take so this is a size 1 list, so we're good there, but this is a size 2 list, so we have to split this in half again. So then 3 becomes a list, and 10 becomes a list, and then we merge in the reverse order that we halved. So 3 merges with 10, and 3 is less than 10, so 3 goes in front. So, and then we merge 7 with the 3 and 10. 7 compares to 3. 3 is less than 7, so 3 becomes the start. And then 7 compares to 10. 7 is less than 10. And 10 compares to nothing, so 10 goes right here. So then this is our newly sorted list. So we take this sorted list, and then we merge them together. Because remember, we go in reverse order. So 4 and 6 merge with 3, 7, and 10. So 4 compared to 3. 3 is less than 4, so 3 becomes the start of the new list. And then 4 compares to 7. 4 is less than 7, so 4 becomes the second element. Then we compare 6 to 7. 6 is less than 7, so 6 becomes the third element. And then 7 and 10 are already in a sorted list, so they just drop down here. So then we have our two halves completely sorted. So what we're going to do is we're going to merge the left half with the right half. So just as we've been doing, we compare the first element of each list together. So 2 compared to 3, 2 is less. So 2 becomes the first element of our sorted list. So then 5 compares to 3. 3 is less than 5, so 3 becomes second element. 5 compares to 4. 4 is less than 5, so 4 becomes the third element. 5 compares to 6, because we always compare the first elements of the sorted lists. 5 is less than 6, so 5 comes over here as the fourth element. 8 compares to 6. 6 is less than 8, so 6 comes here. 8 is greater than 7, so 7 comes down here. Then 8 compares to 10. 8 is less than 10, so 8 comes over here. And then 9 compares to 10. 9 is less than 10. And then it comes down here, then 10 is just left over, so it comes to the end. And that is our new sorted list with the merge sort. So that was my demonstration of the different sorts. For array lists, the selection sort, which takes the starting value and compares it to each value in the rest of the list, trying to find the minimum of all those values, and then it applies the minimum to the first element of the sorted list, or whatever the next one is. And then we get the insertion sort, where we only go through the list once. We take the element and then we insert it into the new sorted list. And then we also have the merge list, where we have all the lists and create a bunch of lists with the size of 1, and then merge in the reverse order that we halved. And that creates our sorted list. So I hope you understand the way I explained it. Hope it helps, and thank you for watching.